Hello, hello, hello. And potentially welcome to this Friday stream. Um, so, during the last episode, I implemented the, uh, what do you call it? Texture, whoops. Um, the texture system. And we now have our textures here. Hi there, YouTube. How are you doing? Texture going. Yeah. Let's see. Let's control the light here. So, that got done during the last episode. Right now, we don't have any way of binding our textures to our objects, but yeah, we'll implement that as needed. I have started a board here on my first board, Miro here. And as you can see, I'm going through the tutorial. We can add some files, it seems. Blah, blah, blah. Okay. Okay. I don't want to find help. Got it. Alright. So I want to create some stickies here. Oh, that's pretty big, isn't it? So we're gonna work on our some game systems. I want an in-game clock. In-game clock here. Can I do shape? I'm gonna do a shape here. And the what? Oh, that's a bigger one. Okay. Okay. Anyway, we can add a tag, blah blah blah. Cluster objects, okay. Tag systems. Can I game systems. Okay, so this has the tag. This is apparently a Miro tutorial. Never mind. Game systems. No. Okay. Okay, anyway, we can group them. We want a simulation. With an in-game clock. We want... What else do we want? We want something like a player. We want a... something... Player controls. And the simulation should of course do something. with our uh, something to the player itself, interact with the player. The controls should whatever. Okay. We want to have some game messages. We want some health bar as status bars. Okay. Okay. Let's start out. Start by building some of this. Great stuff. I'm just gonna slap my ideas on here. We're not gonna use this. Yeah. Okay. Not this one. This one. Okay. So. Let's see. First off, let's see, private, debug related. Let's do a bool. Panel open is true. And let's do let's see. Instance. Okay. Now we can close it, right? No, we can't. Let's do if. Huh? Why can't I close that one? Let me see, in the application, we have the flag here. Oh, oh, we simply store the, okay, okay. I did this wrong then. Okay. Now I can close it. Game controls. Yeah, we're gonna delete that, so it doesn't matter. Okay. Okay, let's redo this. Let's actually delete the, or rather not use the state machine here. let's see our application. Okay, let's remove this. Okay, we will close these. And we have this state machine stuff here. We don't want that anymore. We don't want the player controls here. And is that it? No. Did we actually? Yeah. Okay. Sure. Right now it's not very sophisticated, since it's kind of evolving as we go. Um, yeah, so if you're still interested, I can explain, but it has a lot of caveats since it's not a final system, and it will probably change over time. Okay, seems like we got things cleaned up. We're out of the whole chess thing. And we have our stuff here. Maybe we actually want this to be... Nah, it's fine, it's up here. Yeah, I'm gonna play around with the stuff here. Okay. And let me delete this. I don't need this. It's from the chess stuff. So instead, I'm gonna create a not a class exactly, but a simulation. Infected Drew, are you still here? Or maybe you're not live. I don't know. Anyway, I'll create a simulation, quote unquote class. Let's just do a namespace here. Simulation. Oh, well, okay. Yeah, the system is quite simple right now, so um, yeah. Let's see. So right now we have a uh, quote unquote game kernel, Basically, right now, the game kernel is a struct that keeps our game information. So this is what our logic in terms of core simulation and everything will probably process. Maybe I'll change the layout of it, but anyway. So right now I create a series of tiles when I initialize the whole application. When I initialize the whole application, I create material information through the renderer. Right now it's as you would create materials in other shader systems, you specify the diffuse, the Fresnel, and the roughness. If you're doing PBR, you of course need to do something more complicated, but this method simply passes along that temporary material in a non-API specific format. The material is simply just the information, uh, and it gets stored on the renderer front end in some data storage on the renderer front end. Then it passes along that information to the backend, which is Directx12 right here, which handles the resource allocation and upload to the GPU. So that's how materials are handled. Then afterwards we load textures. Again, the front end here is only required to have a file path. I think in terms of using this API elsewhere, it's way better if we can load things by file path. So again, the front end does some stuff, wants to store the texture in a data storage. Right now it only stores the file path, but right now our textures aren't very sophisticated. And then again, it asks the backend to try to create a texture from that file path. We load from file into some data containers that are temporary. If we fail, we of course then immediately destroy the allocated resource on the backend. If we succeed, we keep on actually loading the data from the mostly CPU accessible side to the GPU side, which does some backend calls here and make sure that the resource is available for the shaders. The same thing actually happens to the materials. So that's handled in the backend. Let's see. So after we load textures, we create a mesh. So again, the front end just takes a file path and it initializes a data parser that is able to handle the OBJ format, and we read from file, and we use that information to do a private what do you call it, front end call to a create mesh function where we pass on our vertices, normals, UVs, indices, and also the file name just for debugging. Yeah, and we create a mesh structure that is basically for one in for now an IDE. we're not really using it that much, and I'll probably change the way that everything works here. We have a vertex offset and an index offset, and by that I mean into a underlying vertex and index uh, two underlying buffers, a vertex and index buffer. Of course, the total vertex count and index count, and then for each mesh we have an approximation of a bounding volume. Since bounding volumes are very neat to have in terms of object picking, and if you want to do collisions for that particular mesh. So uh, uh, we upload the actual resource here to our GPU through a backend call. We first process each vertex and kind of like put them in a temporary object storage. Basically, this is just a composite of these three arrays here. We yeah, and then an additional index array. So we combine the vertices, their normals, and their UVs into a single vertex format that our backend can use, and we create the resource on the backend. And it really doesn't care about the data format, since it will basically yeah, this backend here will simply take the data, interpret it in a specific way, and then it will parse it, and it will make sure that the underlying struct here, or rather the mesh struct here, gets updated with the appropriate information. So the backend has an internal vertex and index buffer that has a particular amount of vertices written to it already. It's just a linear buffer that keeps on increasing and yeah, reshapes if it's overflown. And yeah, um, it tells the front end how this mesh can be rendered from the amount of vertices, indices, and their offset in the backend's underlying buffers. And yeah, the rest is just simply the backend that handles the actual copying of the data to the GPU and making sure that it's on the GPU side of the GPU specific side of GPU memory. You might know that GPUs can have shared memory with the CPU, and it can have memory that is only accessible to the GPU, and yeah, there are different optimizations in regard to something that is solely accessible by the GPU. Anyway, so I calculate the mentioned AABB for that particular mesh through some algorithms. We find the most extreme points along the three axes, and we simply store that on the mesh, and the renderer front end stores the information, which is the aforementioned vertex offset, vertex count, index count, and then the bounding volume. And yeah, that's the creation of resources. So we have create materials, we have load mesh and load texture as our public interface here. This is temporary, so don't mind that, but that's the primary functions that the front end gets, or rather, the primary resource allocation methods that get called on this interface or object or whatever we call it. And then it has two functions that are responsible for handling draw calls and um, debug draw calls. So draw calls are just updating some internal stats, packing our delta time, our camera stuff, our lighting stuff, and then for each submitted draw call, computing a transform. It all gets placed in so-called packets. Again, you might see from the meshes here, it's simply indices and index offsets into the underlying index and vertex buffers. We upload this to the backend for each frame. We have different methods, and then we simply just copy it. This function is not very big, as you can see. And then we call a draw call, which is our registration of different draw call specifics. We have a shadow pass, we have a polygon pass, we have some debugging draw calls, and then we have the UI. So that's basically our renderer API. At the front end, it's very simple, and the goal is that you should have very little knowledge about how the backend actually works. The front end should handle whatever requests the user have to the API through abstracted calls. Yeah, so basically, in order to use this API here, you only need to know how to create a material. Right now, it's not very idiot-proof, but we could make an interface for that. So it got abstracted away, but I'm not sure whether that would make sense. And then you need to know how to specify file paths for the meshes and the textures. And then you need to know how to compile these renderable meshes for draw calls, which is just the mesh index, the material index, and the position and scale of the actual mesh. This will eventually hold the what do you call it? Orientation as well. But yeah, and most game objects have access to something like a transform. Yeah, so later on I'll create something like renderable instanced mesh. Which should hold something like instance count or something. Yeah, since instance draw calls are faster for a lot of instances than separate draw calls. But I hope that was sufficient in terms of a quick overview of the rendering API as it is right now. Anyway, so we have our thingy here, and we started out by creating a simulation thingy. And my idea was that it should kind of like, let's see, system values. I'm not sure. Yeah, that's fine. Yeah, we don't need system values. We have game types here, which has our game state data. Not in the CPP, in the header. So we will include that, the game types here. And I will do this C style instead of C++ style, since I'm not sure. I might migrate into a more C style, since I'm kind of tired of all these. Maybe objects are fine for some things, but yeah. Let's see. Testing. I don't need this. Yeah. Anyway, I'm considering doing something else. Okay, let's do a simulate. And let's do a game state reference game state. I'll do the pointer stuff in C++ style. I know I have areas where I could refactor it, but it's like very simple. So anyway, our application here, common helpers, collisions, profiler, input layer, blah blah blah, system values. Okay. Core related headers, and then application specific headers. Simulation. Okay, we create our chessboard here, and then we have our object picking here. For now, we will put this inside here. Do I reuse it? No, I don't think so. And we will simply do simulation, simulate game states. Isn't that neat? So our application will not get cluttered right now. And let's do a load delta time. We don't need this. I'm not sure we need this, but we can always modify it. Units. Well, we will eventually remove that. We have bounding volumes and we have active units. We will also modify that. actually, let's just do it. Maybe we should just actually just remove the units. And not create them anymore. Yeah, maybe just comment this out. We don't mind loading the model. Yeah. Okay. So right now it won't render anything. Yeah, the pawns are gone. We should probably rename some of this stuff here. So active unit, yeah, I don't care about that right now. Let's set the delta time to our delta time here. Let's actually separate this off, because right now we will do the platform layer tick, and then since we have the input information in the platform layer, yeah, the platform layer is input controls, window controls, stuff like that, and then we have our GUI stuff, we have our simulation stuff here. So this is related to game logic, and it should only be updated after that. Okay, so we set the delta time in the game state to the thing. Let's see. And since one of our goals here is to create a in-game clock, we would want something like a delta time accumulator of sorts. I imagine. Let's close some of this. Game state. Delta time accumulation. Let's see. Okay. So inside our simulate function, should this also include, let's just output something to ImGUI. Whoops. It has no real purpose right now. It's just for debugging. Maybe eventually, if you wanted to do a lot of different mesh lookups, you would want to kind of like maybe cache that information temporary in order to allow yourselves to have more efficient searching algorithms. For instance, a hash map, unordered map, whatever, with the names of the meshes that can give you an index into the underlying buffer with all the meshes. But yeah, right now it's just mainly for debugging. I guess you wouldn't store the name no matter what, the file name. Okay, so now I'm just reading this stuff here. Let's see. Game info. Let's see. And can I actually specify flex? Okay, can I force a specific area? Let's see, ImGUI, window position. Uh, okay. Okay. Omar here says that we can set the next window position. Okay. ImGUI set next window position. Okay. Can I do Yeah, okay, so let's bind it to the corner. What's the condition thing? No condition. Always. Yeah, although it's the same pivot. What does the pivot mean? Did he say pivot? What does that? Okay, test text. Let's see. Okay, maybe ImGUI condition appearing. Null pointer. And then the flags, of course. Let's see. No move, no resize. Alright, let's see. Let's combine these flags. No title bar. No move. No scroll bar. No collapse. No save settings. No focus on appearing. Okay. No inputs. We're not supposed to click on it. No clicking on it. No clicking on it. Buddy. What on earth is that? I don't like it. And let's see inside this ImGUI stuff here. Let's delete it. We have weird flickering. I don't like that. Is it vsync related? Maybe it's related to the vsync stuff. Yeah. Let's see. Maybe if we add no background or just vsync. I don't know if it will stop. Yeah, it could be. It could be. Okay. Whoops. In here. There we go. No background. Let's just try that to see. Yeah, we still have a weird line going on up there. But anyway. Can I set a size? I can't remember. Text ext text v text flags. Is it called label? Yeah, maybe it's called label instead. Label text. Test. I can't remember. Label text. Okay. So it needs some arguments in terms of the stuff. Okay. Pop-up text, bullet text, input text, label text, log text, separated text, text colored. Text wrapped. Okay, maybe I have a ImGUI font. Set window font scale, I guess. There we go, I think. Oh my lord. That's beautiful. That's beautiful. That's beautiful. It's not really beautiful, but maybe if we do it odd, or rather even, yeah, we need to scale the texture. Um, let's see. Yeah, maybe I could select a different font. I don't know. Anyway. Mm, let's see. the documentation at the top of the file. My lord. ID. Well, okay. I need to. Let me see. Label. Pop-ups. Context and forward declarations. ID stack, I think. Not the ID stack. Oh, this is sections. Okay. Uh, where is that section about the ID? Yeah, I like that. I like that. Get IO, blah blah blah. Ah, okay. I'm just gonna skip it, I think. Since it's not an actual control, I don't think it matters much. What did he specify? It was you can use okay, so if I follow his logic, clock, let's see. Let's just do one. It should show a one, right? If I, no. Okay. Well, this doesn't. Maybe it's not even indexed since it's no control. Does it even add item? It does create an ID for it. No, no, the ID itself is 0. Okay, so a text doesn't have an ID, so that's why we're not able to do that. Okay. Okay, let's do float and let's do game state delta time here and game state accumulation. It's totally total, dude. Yeah. Let's open a clock here. Do we have I think it approximates pretty good. Uh, to what do you call it? It's Friday afternoon here in my country. I got off work today, and yeah, I'm feeling a bit silly. So we could do something like float seconds equals unsigned int seconds. We simply truncate the game state accumulator here. Ugh, I'm so tired. Unsigned int minutes equals to the seconds divided by 60, and then hours minutes 60. Okay. Let's do ImGUI text here. My clock is clocking at, and then D, uh, D, and then D. And let's do hours, minutes, seconds. And let's speed this up. So 10 times as fast. Oh, okay. It's clipping a bit here. Oh, wait a minute. This of course needs to be moduloed by 60. Oh, wait a minute. We don't want to do this here. We want to do it here, I think. 24, 60. Okay. Okay. Looks decent, although um, no background, no collapse, no save settings. Yeah, I don't know. Let's do this, maybe delete this. I'm not sure whether that solves anything. And also, in the let's reset the scaling and see what happens. Okay, that works. Doesn't clip there, so maybe it's a bug relating to the scale, or it's the maximum allowable window size. Now it starts clipping here, so I would guess that it's about the scaling, but let's just try adding some white spaces to the end of it. Yeah, it seems like an ImGUI bug. Let's speed this up. It's way too slow. 1000 times speed. Okay. Now that's what I like to see. I'm just gonna wait here all day to see if it actually. Oh, wait a minute! I have made a mistake. Because it should be 59. I think no, shouldn't it? Let me just think. Maybe 60 is correct. Let's just speed this up 10 times more. Yeah, okay. So it doesn't. Yeah, that's correct. Okay, then I think we can do parameters like this, right? Wait a minute. Dot, I think. Is it that way? No. Oh, I can't remember. What's the SPF? Uh, Parameters. Decimals. Uh, let's see, C++. Yeah, maybe I can't remember. Mm, Format specifier, leading flags. Maybe 0. Now we parameters. Oh, I already specified that. This begins percent star. Let's try this. That's definitely not it, huh? This won't work, but yeah, definitely integer. Oh. Uh, well, it's not that I could change it, but I mean, it's way easier if it just is possible to. Oh, that's not it. Okay. Okay, so all of them suggest simply changing the string. Sprintf integer leading 0. Okay, let's see. Let's just try this. Okay, we have a problem here. Okay, maybe. No. Let's start out by doing that. Let me try what you're suggesting. Maybe you're right. Percent 02 D. Okay. Yeah, you're true. Yeah. Thank you. Now we can get on. Okay, we have an in-game clock now. 24 hours. Great stuff. Okay. So we have the in-game clock. The game messages. Whoops, what did I just add? There we go. The in-game clock will be just ticking away. Let's see. And let's do day. Okay, we will be stacking up some days. Let's see. Great stuff. We could wrap it around like 12 o'clock or whatever. Simply by calculating 12 hours times 60 minutes times 60 seconds plus the and we should start at midday, right? Yeah. Well, the rendering is way too fast for great stuff. We've implemented a game clock. Let's slow the time down a bit. And next, we want to implement something like a player character. But one thing I want to change, uh, what do you call it? Is one thing I want to change is the way that these things are positioned in terms of world space. Let me just create these again. because right now our grid here is actually extending over the what do you call it? The origin is up here, but I think the origin is like in the middle of this mesh, and I want the surface of that tile to actually float with the y coordinates of 0. So yeah, just temporarily though, because yeah, I'm gonna do some automated math here to kind of like set the y position. But I guess I could, yeah, calculate it here. Well, instead of 0, let's do game AABBs. Maybe, is it core? Yeah, ABB. And we have ABB half widths dot y. This is the half of the height of the actual mesh here. So if we offset by the negative y of the ABB, yeah, we haven't manipulated the ABB yet, but this would mean that if we were to do the same thing for, well, yeah, I guess we need y positions for our units here. Yeah, maybe we want to be able to handle the y position. I guess. I don't know. Should we create a 2D, 3D game with no sense of verticality? I don't know. Yeah, I also think that 3D is way better. Okay, so the we will set the ABB here, and now we're back in business. But these objects are floating. So what I want to do is to create a sort of player character. So all this stuff is fine. Let's remove this. Pawns are not back. This will be temporary, but we simply scale the volume down here. Our game state here. We have our tiles. Original tile cache is not needed. We do set up a board. The unit stuff here. Let's remove that. We still create our ABBs. We don't need the original tile cache anymore, since we're not creating a chessboard. At least not for now. Oh, not in terms of the chessboard, but okay. Okay. This should remove our code, and we can still click. Let's see, let's change the lights. Yeah, we can still select the bounding volumes here. Okay. So units, we don't need that. We have tiles, we have a position. Well, that's fine. We don't need this right now. It's left over from the chess game. Okay. Tiles, player. Player, let's do a player data. And let's do a float x, float y, and float c. Okay. Let's do a boundary on the player itself, I think. What did I call it? Oh, it's in call. Excuse me, call. Yeah, we might want to do some collision checking, or maybe we actually want a circle, or rather sphere, bounding sphere. Anyway, okay, we create the chessboard here. Game area. Player model index. Okay. Then oh, maybe we should store the mesh ID. mesh ID. And whenever we create our game, we set the game state player data to our player model index. Right now we won't be using this, I think. Mesh ABB. And we could also make this a version where it returns a struct about with the ABB information and the ID. So this could, for instance, return. Let's add that to the comment. But could return a struct with both ID and ABB data. This could be removed if we just pass back the mesh index and ABB data when we load it to remove odd getters on the interface. Yeah, but for now we will not prioritize changing that. So we start the model index. We can do computations in terms of, yeah, I think for quick computing, I think I want to store the maybe float model y offset. So the game state player data here will have a model offset of the mesh AABB dot half width dot y. So this gets computed whenever we load the mesh. Right here, we actually load the size of the AABB of the entire model, which we simply store as a sort of offset of which we can place our model itself in the 3D space, meaning that it will always get offset by half of its own height because the object local center is in the middle of the model. And yeah, we need to offset there. You'll see eventually. Okay. So now we should be able to let's do player. Oh, whoops! This is not our real renderer submission draw call, or rather draw call player game tiles, and we don't need a for loop. Let's just do a game state mesh buffer in place back, and we in our mesh buffer here we pass our simply in place the information here. So let's create a player mesh at the origin just to illustrate my point. Then our scale will be simply 1 for now. I know this is way too big, but we don't care. We will pass in let's see, the game state player data mesh ID here. And we will give it a material of just maybe the second material right now. There we go. So this should create a draw call to draw our mesh. And there we go. So we created the mesh directly at the origin. Hi there, you two. Hi there, you two. Yeah, the UV unwrapping is not fit for that texture. Anyway, so we want to offset every model by its the half of its height. So that's why I stored that parameter on the player itself, because there's no reason to fetch the ABB or whatever from some other point in memory. We can just offset it. Didn't I? Model Y offset. I don't know why IntelliSense doesn't know what I want to do. And our model is simply situated here on the uh, um, y coordinate of 0. Great stuff, but this is way too big. Let's do this all caps. All caps all day, and then a lot of exclamation points. Yeah, we can't have this. Player mesh. Player creation. Let's just do that. We could store the scale itself as well. Maybe just a float. Model scale. Maybe just 1 here. Let's do that. And then we can access the scale itself, or rather the player thingy here. Model scale or what? Yeah, okay. There we go. Looks better, but it's definitely not great yet. Let's do 35. Yeah, that looks a bit better, at least for this model. Okay. Great stuff. Okay, so we've created our model. Um, um, and we have this pretty annoying input thingy. Yeah, I really don't like it, but it's the way it is right now. I'll change it eventually, I think. Core input, input layer. Yeah, maybe we should just skip the seconds in terms of displaying it. That's fine. Okay. Anyway, we have this silly input system. In our simulation here, we'll do display game data. And down here, we want some display player stats. And then down here, we want something like handle player input. We could do that and then branch it out into different sections of code if we wanted to or needed to eventually. Right now, we will do a simple let me see. What's the interface here? Input layer. Oh, it's called input layer. Yeah. Okay. So if we have core input layer is key down, we will do something simple like, well, if the A key is, rather the D key is down, our game state here, player X 0.1 times game state delta time. Okay. Oh, I know why. It's because we actually don't use our model coordinates for rendering it. So there we go. Or what? Oh. Did we move it? Yeah, we did move it. I think it's just way too little. And also our camera right now moves on the same controls, so maybe I should change the input state for that. Let's see, process keys, left key, 4, 5, 6, 7. Okay. Okay, we have the mapped virtual key, left space, left control. Yeah, let's change the camera controller here. Okay. VK up. VK down. VK left. We will do this for now since we don't have a camera that follows the player around. Let's do VK end. VK delete. Let's do that. So now I'm pushing the what do you call it? Arrow keys. I haven't implemented delete and so I'll do that in the input layer. Okay, let's see. The ordering of this stuff here. It's horrible. It's horrible. I need to remap it eventually. This really, really, really sucks. Okay. This really sucks. But I guess eventually it would read from file and read a keyboard map and have some kind of like internal mapping. But this really sucks. Okay. But delete will be 24 and this is the process key state. Yeah. Let's do vk delete. Vk end 24, 24, 25. Okay. Is key down. That's what we're using right now. Let's do vk delete. Vk end 24, 25, right? Was key pressed? Well, we probably won't be using single key presses on these keys, but let's just implement it so we don't wonder why it won't work if we decide to do it. Oh, I spotted an error here. This should be fine, right? Yeah. Now we have camera controls and we can move our camera up to our model here, and then we can immediately see that we have very slow movement here. Great stuff. Okay, let's do this then. Okay. And this is of course the C, and that would make more sense. No, this is actually the X, that's fine. I was thinking about something else. Let's see, W will be up. So this is the C. Let me try to remember. Negative C, is that forward or backwards? I can't remember. All right. Yeah, so it's opposites. Okay. Let's add a set of cameras. We won't be creating a very sophisticated camera, but we will create one that follows the player around. So let's see, camera controller. We have only one camera here. Let's see. Okay, let's write this to a vector of camera. Cameras. Unsigned int current camera. We have a pre-compiled header, right? Yeah. We should probably include it here anyway, but there we go. And we return the address of our current camera. Delete this. And the constructor. It fills out an empty camera. Let's do a mCameras pushback. A camera, empty camera here, and let's do cameras back. Let's see. If current camera 0, we will only be using the standard camera. We will only be able to move the first camera since it's the one that's supposed to be free floating. Okay, so this should almost work. It does work. Okay, so let's do a interface function. We could do active camera here. I think it's okay. Now that's interesting because this is no, it's fine. Let's be able to click from the perspective of the player camera as well. Okay. Okay. Our application should be able to update. That's fine. Get active camera. Let's do a void, maybe inline, camera, pointer, maybe we want addresses instead, or references rather. Yeah. Create camera. And let's do an inline. Get camera index const unsigned int index. We could do an assert if we wanted to, but I'm pretty sure we don't want to. I'm pretty sure we don't want to. No asserts in here. Okay. We like to live dangerously and have no way to debug our code. Let's create this. So it will just create a standard camera. So cameras, pushback, camera, empty. And let's return that, right? Oh. Yeah, exactly. Asserts are for losers. We never make mistakes. Let's see, if I use emplace back and construct it in place, I think I will get uh, a reference to the emplaced object. Yeah, it gives me a reference. Isn't that beautiful? Isn't that beautiful? Okay. We could do something like camera swap and get camera index, where we simply set the current camera index to our index here and use that to return our camera. Okay. Yeah, maybe we don't want to use this. Maybe we just want to force set active camera. Yeah, maybe we want to. If we ever end up in a situation where we want to return the camera as well, we will do that. Although you could just call get active camera afterwards. Well, okay. And it will basically be the same since it inlines. Okay, so this is... Yeah, I guess... Okay. I was just considering how to do it. It doesn't matter much, but since we do get... Yeah. Submit draw camera reference instead. Whoops. This is a pointer, which is fine. Okay. Oh, we have an error somewhere. It gets a reference. That should be fine, right? Camera controller. Oh. There we go. Okay. Okay, so we want to be able to be able to what do you call it? Store a camera, I guess. Player resource types. Does this have a camera? No, it doesn't. Where does the camera? Oh, is it just in camera? Well, I guess. Call camera. So if we do a camera pointer, camera. We can access our camera if we want to. Hmm. Yeah. Game state. Camera. Camera controller. Create camera. We could call it create default camera. Just for that to make more sense. So when we create our game, let's delete this. We don't need it anymore. So inside our simulation, we can simply game state, player data. Yeah, I'm pretty sure. It should be in cache, but well, yeah. Right now we're not optimizing for cache misses. So let's for now do it like this, but let's see, up, down. Okay. One thing is certain, I want delta time to be copied because I'm gonna reference it over and over and over. So let's see, what do we actually do in terms of our camera controller? What are our standard level of movement? Let's see, camera controller. Okay, so we add -5 and 5. Let's do let's do this. Okay, and our application should of course have something like game logic, of course. Oops. Yes, I think most of this is kind of like setting the game state of, or rather the application state. So let's do something like, we do have the input system, right? Don't we? Come and help us. Input layer. Yeah, okay. If the core input layer was key pressed, let's do just maybe F12, right? Yeah, F12 set to free floating camera controller, set active camera 0. Oh, set active camera 0. And we'll do the same thing for was key pressed F12. Yeah, or rather 11. Set active camera. And here are stuff definitely can't fail. Okay. Oh. Okay. So F11. Let's see. F12. Oh, breakpoint. Well, okay. That doesn't work then. Let's do F1 and F2. F1 and F2. We can press the buttons, but it doesn't care. It doesn't care. Did we bind them? No, not camera. Input. F1 and F2. We process the input. Yeah, we do. Okay, so for some reason this doesn't work. Oh, wait a minute. The camera controller gets initialized up here, right? Or what? No, it creates the other camera construction. Did I get active camera? let's debug that. This camera controller, cameras, they are the same. And in our camera controller here, if current camera, we manipulate the thing. Oh, wait a minute. No. Let me just think. F1. Um, hmm. Let me just output this. Swap to player cam. Yeah, it should not be the problem, as we will probably will see here from the console. Oh well, I guess I'm wrong. Was key pressed? Oh, maybe no. Was key pressed? Let's see. Does this not work properly? Oh, let me see. Oh, okay. There's no key called F1, of course. It's called VK F1. There we go. Now we can swap cameras. Yeah, the key codes were wrong. Okay. Let's add the same line of code to our player camera so it has the right amount of pitch. Let's see. Whenever we create it, game state, player data, pitch. Well, for some reason, okay, something is happening differently, but okay. The camera should have specific default values, which it does. Okay, what's the problem then? Okay, so something about the way that we initialize the camera, but I mean, they should basically be the same. So I think there is maybe some problem in terms of transferring the data to the renderer. Let's do debugging related. And just collapse that. Okay, so if we simply swap the camera here, we end up, yeah, so I can move this camera and then even move it more to the left here, I think. No, we can't move the camera whenever, but for some reason, let me just step into this part. Yeah, so the camera controller itself. So the camera's position, Nodix. Yeah, it does have different locations. Let's see the matrices themselves. And they don't seem to differ. So why do we end up? Yeah, it's probably related to the information itself when it gets passed. Yeah, so let's follow the information down the pipeline. It's probably related to whenever I change the thing from getting taking a pointer to taking a reference. Okay, so could we change this to camera reference? Okay, then our backend here. If we do like this, does it change anything? Let's see. Oh, I can't, of course, initialize a reference. Yeah, that's why. I had so much trouble understanding that when hmm. And whenever we huh. What happens when we reshape the vector? I think that's the problem. Whenever we actually create the the no, is that the problem? We do move our camera here, but doesn't really help. For some reason it changes, but it doesn't change. It should be exactly the same camera. It should be exactly the same camera. So the only thing I currently can think of is we're pointing. And we don't force any camera to be set anywhere. We don't force the camera. What if we do get camera index 1? Simply just force the scene to load. Okay. Okay, so yeah, no, it doesn't seem like it. Maybe it relates. Well, let me just check the camera logic here. On construction, we do that. Oh, do we actually in the no, in the camera controller we don't. The right and up vectors are fine. So, okay. I know why now. I know why now. Okay. So our camera here, whenever it gets created, it creates a um, it automatically creates the projection matrix, so that's fine, but it doesn't set a view matrix. So that means that when we create our camera, it might have a position and blah blah blah, but it's not used for anything. Um, but the difference between the player camera and the camera controller camera is that every frame the active camera is set to 0 on the camera controller. We update the actual camera 0, but we never call update on the what do you call it, player camera. So if we add something like player camera update view matrix like this, everything will be fine. Yeah, now I'm swapping between the cameras, but as you can see, I'm moving the player around in combination with the camera. Now I'm pressing the arrow keys, nothing is happening, but if I swap to this camera, the arrow keys work. Okay, so that was the problem. Uh, Yeah, that's pretty nice, buddy. Okay. Um, let's do a another function here. Create camera position. And let's do DirectX XM float 3 position. And we will return cameras in place back camera. And let's see, we have looking direction. Okay, we will need to create a version. A constructor that takes in a camera XM flow 3 position. Which we'll call camera with the position and then a XM float 3. Let's see what's our standard looking. Let's see, forward, yeah. We will just use the default one. Let's do forward is like this. Whoops, let's do. Yeah, basically. We process input through the input layer. So the window proc message handling system simply sends these key state packets, the key index, the whether it was down or already down, and if it's down now, and we process the key states. Okay. Maybe just no problem, buddy. Anytime. Let's just do this. Okay, so we can initialize with a rather position. Okay. Did I? Let's call it add position. And let's do an XM float 3. With the game state, player data X. Let's do this plus 3. And then the C position here, I guess. Let's try that. Okay. Let's try just doing that. Now that is weird. And we of course want to maybe -10. Let's just try that. Probably the wrong direction. +10. Okay. Now we have a DirectX error. +3 perhaps. This camera is so weird. But we'll fix that. Oh, up, down. Move forward, back. There it is. And maybe this is... It still looks pretty weird, huh? It's like we're zooming. Okay. We definitely uh, would want a different... it's not a free-floating camera, so we would like another control set. Free-floating camera. And let's do a what do you call it? Static camera, I guess. Let's do something like uh, hmm. So we want to update the position itself. Um, this updates the position by scaling by the forward vector, but it should just add the position vector, I guess. Maybe move forward, back, aligned, X, C. So we will use somewhat the same terminology, but Visual Studio is not heavy for some reason. Huh? Incomplete type void. I don't know why. More strafe align XC. Yeah, it doesn't. All right. Strafe pitch yaw. Okay. So instead of uh, uh, let's add a vector here. Okay. So this should okay. Huh? Okay. Maybe just like this. Can I do it like that? Just fill out the register like that. Yeah, I think so. Oops. Yeah, okay. We need to work on the directions. Also the amount. Wait a minute. So, yeah, definitely. Okay. Yeah, so these need to be swapped. And I think they're moving way too fast. Yeah, we need to have the same scale. Okay. It's pretty slow. Let's see, const expression float move factor. Okay. Strafe aligned exit. I think this is the minus. I actually want this first. There we go. Great stuff. And everything should be working if we set the player data X to something like maybe 5. Um, that would leave you with a somewhat more complicated algorithm with a lot of if and else statements. Uh, yeah, yeah, we simply create a different camera that we have full control over. You generally don't want to, whoops, I shouldn't do that. You generally don't want too generalized code. You would rather have something where the processing is without if and while statements. And yeah, but the camera follows around, and if I swap to this camera and move the player, the camera should still follow around. And it does. Great stuff. Okay, we have a basic player controller. We have a basic player camera. Um, Maybe we want some yaw and pitch on it to enable us to rotate the camera. We could basically um, copy the camera controller stuff here and add it to our simulation. Right now, this is not. Oh, well, this relies on the camera controller. Hmm. Okay. We could save it on the player for now. Yeah, we could save it for on the player for now. Let's see. Mesh related, position related. Mm, okay, can't remember if it can be negative on the camera controller. Does it support a... Oh, it's a float actually. Okay. Game state. Let's include the algorithm. There we go. Well, that's not great because we can rotate our camera away from our player here. And that's definitely not what we intend. So maybe we want to update the position. Oh, we need separate methods for that as well. Pitch position. Yaw position. Okay. Pitch, rotation matrix, and we update the position around that one. Let's see the yaw. Whoops, we need to, of course, use the other functions here. Position. Whoops. Okay, that messed up quite quickly. Okay. The camera position. Definitely didn't like that one. Let's try disabling the yaw. Maybe we only want pitch here. Nah. Yeah, what I'm doing is not correct. Let's see. um, so let me think. Whenever so if we revert this back, so we would want this to change the forward going vector as well as the kind of like, so if I move this to the side, which is handled by the yaw, Yeah, now I can't pitch. Okay, so yaw is somewhat part of it. So I changed the forward and right vector, I suspect, right? I update all of them. Yeah, because the upward up vector also gets rotated. Okay, but I would want to rotate around point. Not that one, but XM rotate. Oh, okay. Rotation normal. So an arbitrary rotation. The problem is if we want to rotate around the player, not only do we need to update the camera position, since if we're rotating around this one, I mean, whenever I drag the mouse and hold the mouse key down, um, if I want to rotate around it, the um, not only do we rotate all the vectors, we also change the position. A rotation matrix simply changes the base of the coordinate system, meaning that it only rotates the axis itself. It doesn't translate. Okay. How is this different axis? Normal axis, axis. Is it just calling the underlying? Yeah, probably just normalizes the vector and then, yeah. Or okay, if we start out by doing this, so if this was our center, I guess this would be right, but I need to so right here it should start by moving around it. Okay, I'm not sure my math skills are impressive enough to figure this out. I mean, let's see. Let's call a strafe amount as well. Nah, doesn't do anything. Do I want to? Hmm. Yeah, I'm probably gonna look it up. Also, I've been going at this for almost 3 hours with no break. So yeah, should probably call it at least for a little while. Anyway, I'll look into how to rotate a camera correctly around the a specific axis. Yeah. Thank you very much, and thanks for hanging out. It was really nice. Hopefully you found it entertaining or helpful or inspirational or something useful. Feel free to check out the Discord and drop by the channel if you'd like in the future. Oh, I'm happy. All right. Maybe I'll catch you in the future. Anyway, thanks to everyone who tuned in and supported the stream. Hope you'll be well all and keep on trucking with your projects. Yeah. All right. Take care. Bye bye.